So also, we asked Loïc Petitgirard to come and present some work about computing and culture, because as you have been saying, it's something that we have been talking about during all the week, like values, culture, technology, what will be the culture and the economic system of tomorrow. So we are going to look today at the past and how it evolved in different countries, because it's in the US and France. And so, yeah, so it gives you some input. So thank you, Loïc, for presenting this. So you're an associated professor at CNAM. Yeah,
that's right.
Yeah, right. And you worked on physics, mathematics, and then you have a PhD in history, isn't it?
Yes,
so
that's it.
Yeah, so we talked also about interdisciplinarity during this week a lot. So thank you for doing this talk, and the floor is yours. 35, 40 minutes.
Thank you for the invitation. And well, I'm now an historian of science and technology, and an example of interdisciplinarity, as I see. And so I guess, what I've heard this morning, you've talked a lot about the future. Now I'm trying to get you back in the past, and so to say 50 years back in the past, and to discuss the specific decade, the 1970s, when microcomputers were just going on the market. So, when discussing with Lou and Thibault, preparing this talk in July, they asked me a lot of questions they wanted me to address. And so this historical exploration, I take it as an opportunity to address a few big questions. They are too big, there are too many questions, but that is, I try to give you a few insights and few answers that might be of interest in your talks. So the first question is about technology and culture. What is the importance of cultural context, cultural biases, trainings of people in the technological trajectories, and what it means regarding the microcomputers history. Second would be what is the importance of outsiders in the technology, in the history of technology, because I will present you, the main actors of microcomputers history were outsiders of this mainstream computer business that was, the leader was IBM, so the huge manufacturers, and the importance of being an outsider in the innovation process. And third questions are about the innovation process itself. Why and how did those actors innovate in the 1970s? And I try to focus on successes, but also on failures, because failures, they give you more lessons about the innovation process, and trying to give you also a taste of the constraints and obsolescence that those actors were facing 50 years ago. So those are the big questions. And so my talk will be twofold, because I think none of you know, or maybe some of you know just a little bit of this history of the 1970s. So first part will be really to give you a taste, an overview of this 1970 decade regarding the history of computers. And then we try to, along this talk, give you a comparison between two different cultural contexts, France and the United States in the 70s. And along this talk, I'll try to give you a few insights and answer to these questions. So, as Anna said, the questions are too big, and this history is very complex, of course. So I'm going into several severe simplification in this history. So apologies for this, but I hope it gives you enough flesh to think about it. So, well, let's go back to this to 50 years ago. In so-called, I call it a decisive decade in the history of computing for many reasons. And I decided to start with this first French microcomputer, which is referred now as one of the first microcomputers ever designed and built. It's called the Micral, which means small in French slang. At this, well, still today, but we don't use this word very often. Micro, it was invented in 1972, manufactured 73, and sold in France mainly during this decade. So of course, it doesn't look like a microcomputer. Because it has no keyboard, it has no screen. It looks like an industrial box, a gray box, of course. And we can question the fact that it was named microcomputers, but the patent office did not receive this name microcomputer. They didn't want it to call it a microcomputer at the patent office. So it was very problematic in this sense. So it's a good question. Why is it a microcomputer? Why did the inventor of this machine, François Gernel, a French engineer, call it a microcomputer, but not in the first instance? It came in time. So at this time, at the end of the 60s, a classical computer would be this size. This was the smallest of this at this period. Was a so-called mini computer. 1970, 1969, 1970 was the bestseller and the blockbuster of the mini computer, where a human being size. The PDP-11, the PDP-9 were the DEC bestsellers at this time, and of course it was produced in an industry which was rather young. Electronic computers were invented in the 1940s, and the IBM was the bestseller in the 1960s with huge mainframes that were the size of this room. Those were the usual computers of the day. So the micro, of course, it comes on the market. It comes on this history among two categories: the mainframes and the mini computers. It has no keyboard, no screen, no onboard memory, nothing that you can associate today with a microcomputer. Okay. Of course, the advent of microcomputers business, you associate it with brands and names and typical machines, Apple, Microsoft, Intel, and IBM, of course, because of the IBM PC, which is the machine we use, and which is the machine just below there, the IBM PC. And all was invented much after 77, and the IBM PC itself was built in 1981, so much after the micro. And it also is a matter of the fact that the business industry at this time, they did not want to go miniature. They didn't want to go micro computers because it was not on their what we call today a roadmap. Okay, there was no business opportunity for IBM to go and to invent or to build a microsystem, and it was even very difficult for IBM engineers that were trained. They were trained for making huge computers, so they had no idea how to build a miniature one, to design a miniature one. So IBM took on the micro turns much later after 1981. And what is interesting, as I mentioned in the beginning, is that the outsiders made the way. They demonstrated that it was interesting to build, to design, to manufacture, to sell microcomputers. So Micro is an example. Apple is another one. I'll give you a few of many other examples. And all of them were produced in very different cultural contexts, very different technological, industrial, cultural contexts in many countries around the world. France is an example. We discussed with Giovanni the Italian case, German, UK. Every story, every country has its own story with different cultural perspectives. So the relation between technology and culture has different meaning in different countries. But they all together, they demonstrated, especially and maybe unwittingly to IBM, that it could be a real business opportunity that IBM took on in 1981 with the PC. We use it every day, everywhere. Okay, and nobody uses a micro today. So there is a classical narrative in the history of technology, and especially made by former computer engineers and so on. There is an idea that the history of computers is just a matter of downsizing the size of the computers and growing the performance of the computers. So there would be kind of a linear history from the beginning to the IBM PC. My talk and my point is that something really different. There's no linear history there at this point between the mini computers and the microcomputers. And this history is much more interesting than this idea that there's a linear history. Because the designing of microcomputers made by those outsiders, they built everything from scratch. So to say, so they built the machine, they had to design their software because no operating system, no application from mainframe computers were adequate to miniature systems. So they have to invent everything from scratch, from the hardware to the application. And that is when those outsiders decided, well, why not make an application for families, for kids, for video gaming, for graphical design? Because was of no interest on the mainframe computer or on the mini computer, but it could be interesting for new users, maybe new consumers. So that was the idea. That is the dynamics that started in the 1970s. So and that is precisely the dynamic that showed IBM and the world that we started at the beginning of the decade with the idea that mini computers are enough to do whatever you need with a computer. And 10 years later, IBM went in the business, and they make their advertisement saying, okay, you need a microcomputer for everywhere and whatever you need. So in 10 years, it changed the picture, the landscape completely. And it is a matter of culture, of local and global culture, because of course there is a narrative of a big technological, industrial, cultural turn after 1968. I'll go back to this post-1968 context, but also an expression of a specific national culture and context during this 1970s. And the R2E micro is, I think, a good milestone and a good example to enter this and to understand this dynamic playing during the 1970s. So hope this short overview is clear. Now I want to really enter the creation, invention, designing of the micro to give you a more flesh about it. So as I mentioned at when I first show you the picture, this is not really a microcomputer. It was not invented as a microcomputer. It was invented as a scientific instrument by François Journel and R2E. It was invented as in a contract dealing with the INRA. INRA was the Agronomic Research Institute in France. So it has nothing to do with computer business or whatever, but they needed a scientific instruments that were smaller than what a mini computer could do, a scientific instrument that were put on the field, in wheat field, in corn field, to take measure automatically. And that is precisely what micro was intended for at the beginning, just to make another scientific instrument for agronomic research. But at the same time, they realized they were making something much bigger, much more interesting than just a scientific instrument. They were making something that was really to be implemented wherever you need automatization, and then wherever you need computation. So that was the invention really of the macro, is the story of this move towards computing. It took place at R2E, so Réalisation Études Électroniques, which means designing and development of electronic device. It was situated in the south of Paris, in the suburbs of Paris, and it was a very young startup. It was created in 1970, and as a spin-off, another bigger electronic manufacturer. And the special system team of Intertechnic moved to create this startup to manufacture custom-made miniature device. So that was the first implementation of the Micral was for cornfield measurements. So the Micral is inside this big box, and then they move to making this a more modular, generic device. So interesting is, what is this startup at this time? Well, first it was quite a bold startup, because they had no idea how to answer the question of INRA, but they made it in 6 months, thanks to François Gernel, who had never in his life invented a microcomputer or ever invented a computer. So in 6 months, they moved from electronics to computer systems in quite a bold move, so to say. So they had a very technological project in mind, because they wanted to miniaturize system. They wanted to make automatic system, and they knew that Moore's law was on its way. So miniaturization was a good perspective for electronics. And interesting is that they gathered the best skills they had in their professional networks at the time. So they took engineers from Intertechnic to go with them. It's a matter of generation, and it's a matter of generation knowing also that it was really a post-1968 culture. They were all part of this generation that passed through this cultural sociological critique of 1978, which was an event in the French history, but not only in France, and where the motto where this small is beautiful, and small is beautiful is the name of the book by the economist Ernst Schumacher, and maybe you see the undertitle there, A Study of Economics as if People Matter. So they really share this idea that, okay, economy is growing too big, so we have to change our scale and go back to the scale of the people themselves. So making things small, making things for new user was really on the agenda, and of these new young engineers at Air2E, and they really played on this, and they played on the codes. Well, for the French readers, you can see this. This is an advertisement for the R2E products, and with long-haired people that were famous in this period, and really they were part of this post-68 critique, quite a critique of capitalism, quite a critique of a counter-cultural critique. So that is why they moved. They were reinforced in the idea to go miniature. Not only to go miniature for going miniature, but going miniature for new users, a new way of using those devices. Of course, what was the key to the invention of the Micral was the microprocessor. Microprocessor was invented in the United States around 1970. And the first Intel chip was on the market at this time. And interesting is that this new generation, they jumped on it. Really jumped on this Intel devices, and although they had never designed a computer, they saw what was in this chip. They saw what the opportunity was that was in this chip, and they make it the base of their own industrial project. At this time, you must realize that at this time, Intel did not know what they would do with the microprocessor. Nobody knew at this time that a microprocessor would be the major and main chip of microcomputers. Okay, so you have to realize they sold it to elevator manufacturer, they sold it to automotive manufacturer, but no, they did not solve those chip to computer industry. So it was a move that was made by those young engineers. They didn't know anything about it, but they learned it on the field. But making it, they were somehow we could call them makers, and so they realized that this chip can do well maybe everything they wanted to do. And that is what they precisely first dealt with the INRA, making the scientific instrument for the INRA. But they they made much more in the micro. They made several compromises with this in this electronic device. They made it modular so that we could fit any application they could imagine. They, of course, the first Intel chip, they were very low, they were slow performance. They had very bad performance regarding computation. So they tried to balance it with machine-to-machine system for communication. They changed the packaging. They made it very portable, and so on. So they made a lot of choices that were also constrained by the fact that, well, this chip was not cheap. This chip was quite slow, but they tried to make a very low cost by the design and by the operating of this micro. So something you can say it's very sober by design. It's very austere, as you've seen it on the picture, but very reliable, because it has to, if you sell one, it has to last for years in their mind. So they made a lot of compromise, and very interesting in the way they saw it. And the micro you've seen is the first of a few years of creativity, intense creativity at R2E, because every new microprocessor went on the market, they invented a new microcomputer. So they started really a strong, heavy, intense creative process there with difference in several micro. They kept on the same compromise, the same idea that miniature system would fit every, they would invent every new users and new usage. And it was user-centered design, because they turned more, they produced more and more specialized system. They were multitasking system, networking system. They put on the Micro M in a small network system. They made it portable, and they made a lot of different machine, and even what we call a microcomputer with a keyboard and screen, a hard drive, and so on in 1977. And they sell it to business and banking system. And they made portable computer, 1978, and they made a lot of other device. And every 6 months, I would say, they imagine new devices. And they changed also the way they advertise for their systems, playing on new codes, playing really from a very serious to less serious. I think that was completely different. If you look at the electronics journals at this time, was really quite weird sometimes in this business, and of course also very serious application and system. So R2E was quite a success. If you look at the numbers regarding numbers of selling, they sold hundreds, thousands of micro during about 10 years. Of course, 1,000 microcomputers today, seen from today, is nothing. Okay, but it was quite a success at this time, mainly for business users, for professional users, and they kept on with their dream of a global transformation project, going back to the people, because people mattered. That was this idea. But well, every 6 months with a new hardware, new software, it was too expensive for such a startup. So they were bought by their competitors, the Bull, which is the French IBM, national manufacturer of computers at that time. So Bull bought R2E at the end of the decade, so it weakened completely the creativity. There was no interest working at Bull, according to Gianna. It was quite a dramatic turn, because they wanted them to produce a copy of the IBM PC that was going on the market in 1981. So it was absolute no interest in doing this for Journal and R2E. So now I hope this, well, you can follow me, you can follow this history, or briefly, or just a few key points. I want to give you a few key points on what happened at the same time in Silicon Valley in the United States, and to give you some more flesh about why I consider Micron a milestone, why I consider this IBM PC the second milestone in this history, and what's the connection between all this, and what are the other outsiders of this in this history. So, as I said, there's no direct connection between the PDP and the IBM PC, because the PDP was quite an inspiration, I must say, for the Micro, but not the only one. And there was another trajectory that started in the United States, 1974, with the Altair, and another complex narrative going to the IBM PC, and new actors and different contexts. So a year after the Micro was on the market, it was sold in the United States in 1974. This machine appeared on the American market, the Altair 8800, which looks like very much like the Micro, but it's not exactly a copy of the Micro, but it was strongly inspired by the Micro, and it's a very similar machine to the Micro. They never admit that it was strongly inspired by the Micro, but they saw the Micro before making this machine, and it's very similar also because the manufacturer was not a computer industry and not in the computer business. It was also a scientific instruments manufacturer, nothing to do with computers at that time. And they put this machine, so MITS was the manufacturer. It's very low-brow machine, no computers, no screen, no software, nothing on this machine. But the users and the consumer, the buyers of these machines are much different than what R2E was addressing at the same time, because they were really outsiders in the industry and the business, and they grew on selling those machines to amateurs of electronics, not professionals of electronics. And this was a strong and growing community in the United States, especially in the Silicon Valley, because a lot of them gathered in clubs such as the Homebrew Computers, famous club in the Silicon Valley. And they gathered buying themselves computers, buying and making themselves computers, buying kits or buying the Altair, and making and trying and innovating as amateurs. Among those amateurs, maybe you've recognized the guy on the right hand side. No? Can you? The young one, Bill Gates. Is it Bill Gates? Yeah, it is Bill Gates. The man on the right is Bill Gates and is co-founder of Microsoft, Paul Allen. So Bill Gates, he bought this Altair 800, and what did Microsoft sold in 1975? This was this punched ribbon. It was basic language for Altair 800. Okay, so they started the business for Microsoft selling those punch ribbons to other hobbyists in other clubs around the United States. At the Homebrew Computer Club was those two guys. Maybe you can recognize on the floor. This guy is Steve Jobs. Steve Jobs was a member of the Homebrew Computer Club. The other one is Steve Wozniak. They were the co-founders of Apple in 1970. And they designed it in 1976, and they bought and they sold this machine at the Homebrew Computer Club at the end of the 70s. So the dynamics here, you see, is nothing to do with R2E in the French industry. They are outsiders, but they are another completely different ecosystem. This ecosystem is made of students in campuses. It's made of hobbyists, of amateurs, and a few industrials such as MITS, the inventors of the Altair. And those people, they build their machine themselves. It's very DIY, do-it-yourself machine. And when inventing them and when building the machine, they also invented the way they wanted to use this machine. So it was really another way of innovating with this machine and consuming and using and inventing new things for this machine. So it was And then those startups, as Microsoft and Apple, which are no more startups today, they started as a basic shift from the communities. They started in the community and they shift and they get outside their community. So the major difference is that the users in those clubs, those hobbyists, I would say they saw even further than what was at stake at R2E. They wanted really to give access to computers to every citizen in the United States, so to say. It was much a dream of democratization of computing. And it was also really a matter of appropriating the technology. You cannot use a computer if you don't build your own computer. It's a matter of empowerment of users by the making and by the using of technology and computers. So it was a clear different cultural context and bias in this approach. And when I say that among those people, Microsoft and Apple, they shifted, they went out, they created tension in this ecosystem and among the hobbyists, because in this letter addressed by Bill Gates, 1976, open letter to hobbyists, it just clearly stated that if you want really a microcomputer business to start, you have to stop hacking my software. You have to buy my software and stop hacking and sharing openly my software. So it created a lot of tension inside the community, but that's precisely when Microsoft started its business. So if you compare it to France, as I said, it was much more a matter of engineers. It was much more a matter of industry, of business, even at the size of R2E, but also at the size of Bull. Bull was the future buyer of the R2E business. So nothing to do with those people from the clubs you've seen at the beginning. So there are two parallel histories, and again, there will be another parallel history in the UK, in Germany, in Italy. But this is the French. This is the French way, the French history, with finally, eventually addressing only professional users, whereas in the clubs, among the hobbyists, they were starting to address families, started to address a new video gaming business. Apple did address the problem of graphic design on their machine, and so on and so on. So much more open to new systems and new users in the Silicon Valley. So R2E was really innovating with a dream about addressing mainly professional users. And in the United States, they paved the way to this idea of personal computers for every users, be they professional or private users or families. And this is when IBM enters the business, because this was the decisive and next step in this history was when IBM created the personal computer, the PC, and it changed the story completely. It changed the dynamic completely, because IBM was strong enough to impose the standard for what is a microcomputer. So even if the IBM PC at this time and for years, it's been a very poor machine, it cannot be compared to Microl system. It cannot be compared to the best English or Italian system, because they were much more performant by their design, with the user interface. There are many more adequate softwares in the microcomputer than in the IBM PC, but it was written IBM on the IBM PC, and that changed everything on the business. IBM chose not to use IBM stuff in their own machine, so they decided for the Intel microprocessors and the Microsoft software, which made Microsoft and Intel the big winners, of course, in the 80s. So it has major consequences, of course, because everybody wanted the IBM machine, because nobody questioned the fact that a computer is an IBM machine. So and with the IBM PC was different, because it was the same machine for everybody. not adapted for a user or for a specific use. It was the same machine for everybody. And this is a very successful story of IBM, because not only they did not sold thousands, they sold millions of IBM PC in a few years. So IBM, Microsoft, Intel, they were the real winners. And of course, a lot of what was invented in the 70s goes in with the IBM PC, because word processing system, you use Word, spreadsheet system, they were all invented in those clubs I've talked about, but they were embedded in the future versions of the IBM PC. So what happened in the 70s was decisive in creating all this, demonstrating what was interesting, what could be made with those computers. And then the IBM PC was just to take it over and put it on his own machines. Only a few competitors from the 70s were passed through this year. Apple is just one example of those first comers on the microcomputers business that went through this tsunami of the IBM PC, and changed, a lot of things changed when IBM PC were started to be cloned by Asian system and so on. But it was no more a matter of what was invented in 70s and goes to the 80s. So that explains why at Bull, the French IBM, they chose to stop making microsystem to turn to IBM. So interesting is, as you can see, the context is as a major influence in the way innovation was processed at that time. Of course, there was, interesting is, there was a lot of creativity among those R2E, our homebrew computer clubs and things. But their transgression towards the future users and the transformation of society was different in the clubs than in such startup as R2E. And I think it was clearly related to a different understanding of the relation between technology and society, so to say. Because at R2E, as I said, they were French engineers. They were oriented by their trainings. They were oriented by the business, and they were driven. It was a business driven by engineer. It was although they talked about small is beautiful, they were engineers, and they were very serious in the way they wanted to make this term, this change in the industrial and economic world. And so somehow they thought that, okay, society will follow somehow. So it was really a top-down vision of technology and society. Whereas in the clubs in the Silicon Valley at the same time, they took on a less serious turn. So those users, those hobbyists, they were at the same time the consumers, the makers, the innovators, the inventors, and it was much more kind of a bottom-up vision of society, of the relation between technology and society. And what's interesting is that R2E, they were aware of what's going on in the Silicon Valley. They went there, they tried to sell their micro, but they didn't really understood what was this term, what was going on, and they didn't really never sold a micro in the Silicon Valley because they didn't understand this. Interesting also that there are many representations and cultural representation at stake. In the clubs, as I mentioned, Steve Wozniak was among those evangelizers of digital technology you've seen on YouTube and TV later on, but he started his job in those clubs in the 70s. But at the same time, in France, there were also a few guys inspired by what happened in the Silicon Valley, going back to France and starting to evangelize everybody with the Silicon Valley ideas. But the problem, it only gave rise to big techno-political projects. We cannot do anything but huge technological political project in France. So, and it has no connection with R2E at this time. So this politics, they were at the same time, they were focused on not on computers, but on telecommunication networks and system, which gave rise to the Minitel system in France. And they were really blind to what happened just in the suburbs of Paris at the same time. So there was this strong domination of a strong representation of computing in France, that a computer, a serious computer cannot be anything but an IBM huge mainframe computer. So what nobody cared about R2E and in the south of Paris. So just to finish with, as I mentioned, I hope you've understood this. This decade has been decisive in my opinion, because it has those outsiders have shown how to overpass the constraints of the industry, of the computer industry of the 1970s. They had very cultural and a lot of ambitions, political ambitions, cultural ambitions, and redefining the how to use a computer, how to sell, how to buy a computer, how to make a computer, how to give access to computer to the more and more people, and that made the job for IBM in the long run, of course. But maybe the story could have been different. But this was the end of the story. The IBM PC took it over, and somehow IBM put it back on track, put it back on, okay, let's start business as we did before all this happened. And Moore's law is now on the foreground because microprocessor is the main chip of the microcomputers. So there's a Moore's law for microcomputers, for microprocessors, and for microcomputer. So everything is back to normal. Let's go with this PC business. And it was really a big decade for the computer business, although those outsiders just wanted to, somehow they wanted to avoid this, but they participated in this. So I hope this has been of interest to you, and thank you for your attention. And maybe you have some question I can answer.
Thank you. Does it work? Yes. Thank you so much for this very interesting presentation. Also, it's really related to what we have seen during this week, like imaginaries, narratives, and the role of culture. So please ask questions as Bill said. Okay, so first maybe Adrien, you're closer.
So just raise your hand. So 1, 2, 3, just to see how many we have.
Okay.
4. Okay.
Thanks for your talk. We speak more and more about resources scarcity in new technologies, and I wondered if you have any insight about the necessity or not to design for a specific purpose instead of the general purpose design we do, creating very powerful personal computers for anyone, while while with the lack of resources, we may end up trying to focus power and focus capacity into necessity instead of what we have currently.
Yes, I'm not sure I can answer it all, but I can just go back to this situation. I've talked about the constraints in the design of the first microcomputers. It was a time of scarcity. It was a time where every byte of memory was expensive. So everyone until the end of the 80s, they were driven by the fact that every chip, every kilobyte of memory was expensive, was scarce. And so they have to design it taking this as a major constraint, which after the let's say when we entered the 21st century, it was completely different, because the kilobyte of megabyte, gigabytes of memory, it costs no more. So the design of the system was it turned to be completely different. But at this time, when they invented the micro and the several different micro, they were constrained. They had no choice but to make it for specialized machine. They could not make a generic, completely general machine for every use and everything. At Xerox Spark in the Silicon Valley, that's where they start and innovate on the word processing machine. They built a machine that was just specialized for word processing. And they made the job in an excellent way, but they could not play videos. They could not, there was no possibility for networking with this machine or whatever. It's just a word processing machine. It was the best word processing machine at this time, but it could do nothing but word processing. And IBM PC changed it all because they tried to make the machine that could make everything, but it made everything bad. The worst way it was a very bad word processing machine. It was very bad spreadsheet system. It was very bad for networking. It was very bad for every use. But it was the first move towards a non-specialist machine. But every serious engineers and hobbyists at this time, they knew that they just could do specialist machine because everything was expensive and everything was too slow to make something more generic, I would say. I don't know if it answers the question, but
almost. So do you think if there's a comeback in scarcity and in resources monitoring, we'll come back to more specialized devices?
I don't know if it will come to more specialized, but it certainly will be a constraint, as they had the constraint. It's not exactly the same constraint as in 50 years ago, but interesting. The other thing that is interesting is the more constraints, the more creativity also, because they invented a lot of things being very severely constrained by the technology and by the cost of it. So my hope is that we will keep on the same creativity with the new constraints. That's the only thing I can I can tell.
Okay, thank you.
Thank you. Just we will try to keep it short for the answers. I mean, try. I know you try. So, but yeah, let's go because we have 3-4 questions, and we have 8 minutes. So yeah.
Okay, quickly. You said that the hobbyists.
Wait, it's maybe we don't hear you in.
Okay, so you said that the outsiders, they had this idea of empowerment of people, of making a little bit, bringing the technology to everybody, and not only to engineers. So, but at the same time, they went back in business, and the open letter from Bill Gates shows this, because that's where he says, okay, now you have to buy for my OS system, and this will not be open source code. This will be closed code, and I'm the only one who knows it, so you don't have the code anymore. And I think this brings the open source free software people branch in the story. Could you please say something about it, because it's very interesting?
Yes, it's a big subject also, because well, the open source it started before this period. The open source movement, the open source ideas. It started really with the Unix community, which was born in at the Bell Labs, which was a private company. One of the Bell Labs was the biggest laboratory in the world in the middle of the 20th century. So, and it started with a strong community made of academics and engineers, and the Unix community they had this ethos of open system strongly. So, and so coming back to the clubs, there were thousands and tens of thousands of people in those clubs. So Bill Gates is just one in the middle of an ocean or a sea of hobbyists, but is the one bringing this idea that, okay, I want to go business with this, so stop sharing and my stuff. But it was only one, well, a few one, because Jobs and Wozniak and many others, they also decided to go off the open community. But this open community was much broader than those few well, a few entrepreneurs of software.
Okay. Yeah, thank you for your talk. I have a similar question about the sociological aspects of these groups in the 70s in the USA. There's always this narrative that they are just passionate and they are non-related and very differentiated about very different from the engineer, but are really technical people. But are they really, in fact? Are they not professional that already works in electronics or science? And do they have the same feature, in fact, that these engineers? And finally, was it really just for fun, or Bill Gates was Bill Gates the only one to seek a business opportunity in this club?
No, it was not the only one, of course, but well, there were many, I would say many, maybe tens or hundreds of people trying to make business out of it. But of course, Bill Gates is a clear example of success. And even if he was kind of a hacker himself, and he entered the business very with fierce and a lot of boldness in his way of making his business. But Bill Gates is an archetype, and there are many others behind them. A lot of failures also, business failures, that happens with business angels financing those few ventures in those clubs. Going back to the sociology of it is very, very diverse, those communities, because it's made of students working in mathematics, physics, computer science at the university, very interesting in making their own stuff during their study, and maybe some news for their study, not with no idea of making a business out of it. There are some academics, some professors, assistant professors in physics, mathematics, and biology, and so on. There are some bankers and simply electronics amateurs, like radio amateurs. Okay, and among those amateurs, there are engineers, there are technicians, but there are also just amateurs. Just they are amateurs. They love technology, and they're fond of making their own machines for making their own machines, and that's it. And there are industrials like MITS. MITS was a scientific instruments manufacturer, so they really were aware of what they needed to be aware of what's going on in those clubs and what machine they could sell to those hobbyists also. So it was very, very diverse. I don't know if there was a lot of women, because I don't know the diversity in this related to this genre problem. I guess there were not so many, but there was still a lot. I would say everyone could enter those clubs. There was a few attempts of clubs in France. Interesting is that those clubs in France, they were severely driven by engineers, and especially by telecommunication engineers. They made their clubs certainly dealing with their own view of what a computer could be, of how they could use it in telecommunication systems. So the French clubs are less diverse than those American clubs, much more open to whoever is interested to come to the club. So just to give you a few answers.
Thank you. We have another question here.
Brilliant. I'll keep it really short. First of all, fantastic presentation, and I love the focus on French contribution to innovation in ITC. a lot of the time you see the focus is on places like Silicon Valley, but I think countries like France and Britain have done amazing. So thank you for bringing that up. My question is more to do with the idea of hobbyists versus industry. What do you think has contributed more to ICT as a field, and why?
In the long run, of
Yeah.
course, it's the business. It's the capacity of strong engineering teams to put on microprocessor on the field, on the game.
Yeah.
But what was important, I think, is that the use and the users and the how to use, how to create new users, watch much more on the side of those hobbyists and amateurs than on the side of the business itself.
Do you think that's, sorry, do you think that's because they understand what people need better than maybe?
I think, yes, that's certainly part of this. Well, there could be parallel to different stories in different business and find the same. Like there's a famous story of Kodak. They invented the digital cameras and everything, but they have no idea who were who are the future users of it and how to use it. So they miss this. Somehow they miss this hobbyist community to get themselves and to demonstrate to Kodak how it can be used and what we can make with digital systems. So
just missing the
they miss the opportunity. So just to make the parallel, and on this side, in computer business and in ICT, the importance of users, it has to go back to users themselves. I think so.
Brilliant, thank you.
Do we have another question? I have one, but maybe
I have one too. But yeah, you can. Any other question?
You can go to.
Go first.
I had one question about how you presented a non-linear history of computing, and then I was wondering how you spread this message in your activities to engineers to make them understand that they repeat a story which is actually, I was going to say not true, but true is like there's maybe no truth. So how do you do that in your work as a researcher and teacher, maybe animator of other activities?
Just like every other academics. I mean, when you're invited to discuss with engineers, you are really aware and prepared mind to what I've tried to say. So there's no big tension, no big discussion with you about this nonlinear aspect of history. Facing engineers from the computer business, it's different because they are not prepared, or they don't want to change their narrative, really. So, and that's in every part of the history. The history of technology is always facing those pre-narrative that engineers have in mind. So whatever the subject is, you can go with train or automotive, and whatever business, you will face their narrative, which certainly never fits the historical narrative or the interpretation that historians can make of this of those narratives. So it always is a bit difficult, and so but as academics, we try to diffuse, we try to talk about it, we write articles and so on. That's the only mean we have to share and to change a few minds about those narratives, really.
Thank you. Yeah, that was a brilliant presentation. I really found it very interesting. And in what you, in one of the previous questions, you said something like, in the question there was something like what people wanted, and then they went for a business model that can provide that. But I feel like, is it really something that consumer needed or wanted, and so they bring that model? My question would be now, as we have like planetary boundaries and needs and limits that we know, do you think we can still afford going for developing general purpose technology? And if yes or not, what would be the role of like European Commission or road mapping and that kind of stuff in that development of generating technologies?
That's a too big question.
Okay,
No, sorry. Just it's quite a joke, but of course I don't have the answer
sure,
to it.
sure. But what do you think about that?
My guess is maybe if in these role mapping, I don't know the quota of users of citizens, so to say, of John Does in those road mapping community, but my guess is there are none in those road mapping communities. So that could be a first move, is to just to make enter citizens and really kind of, not to say democratization of road mapping, but would be a first move towards changing the minds and changing what a roadmap is for and for whom it is, and then think maybe, of course, when discussing at this level, could discuss is it smart to move to generic system or not. And I think there's no prepared answer outside those kind of community and outside those kind of road mapping groups.
Thank you.
Great, thank you.
Last question,
yeah.
or are we good to go?
It's time to go to
Okay,
museum.
Yeah,
thanks
yeah.
a lot.
Thank you so much
Thank you.
again. So round of applause.